Chapter 2, Reflection. So the next two lessons will be about reflection. Can you find the difference between the two pictures here? The water on the right is the Victoria Harbour, which is wavy and therefore not a smooth surface. The closer part of the left one is a pool of water here, which is calm water, so the smooth water surface produces regular reflection and forms clay image. Clay images are formed by plane surfaces only, where there is regular reflection, where the lights are reflected in this way. While wavy water surface and most solid surface cannot form clear image, the light rays are reflected by diffuse reflection. The light rays appear to be irregularly reflected. Nevertheless, diffuse reflection is important. We see an object because there is light from it enter our eyes. Numerous objects such as the sun, LED, television, they emit their own light so that we can see them. Most other objects cannot produce their own light. They are non-luminous objects. They can only reflect light to our eyes. When light are reflected by them, usually by diffuse reflection, then we can see them. For example, the rose here reflect red light from the sun to our eyes so that we can see that the roses are red. On the other hand, all other colors of light from the sun are absorbed by the roses. Using the same principle, can you explain why leaves are green? And for question 12, you can say absorption spectrum of chlorophyll, A and B. Can you use this graph to explain why leaves appear green? So in this lesson, you are going to do a very simple experiment to verify the laws of reflection. You will be given a left sheet with a very big projector which look like that. And then you set up your apparatus just like these pictures. And what you are going to do is to measure different angles of incidence and measure the corresponding angle of reflection and see how they are related. And here is a reminder for you before you start your experiment. In order to mark the path of the light ray, you may have to make crosses on the piece of paper given to you. You should mark the crosses as widely separated as you can, so as to mark the accurate path of the light ray. So you are going to measure different angles of reflection for different angles of incidence. When the angle of incidence is 0 degrees, what's the angle of reflection? When the angle of incidence is 15 degrees, what's the angle of reflection? And so on. So you are going to draw 6 different light rays on your piece of paper. So how can you label the light rays so that you don't mix them up? Let me spend a minute on question 17 to make sure you understand what the question asks you. Now there is a plane mirror, vertical, and now the vertical mirror is going to turn by the angle theta. You are asked to find the angle turned by the reflected ray. What does that mean? First of all, when there is a incident ray, black in color, that go this way, and then it will be reflected back to the original direction. And now the mirror is turned to the red direction. And so you may know that the normal may also turn as well. So now the incident ray will go this way, horizontally, and then hitting the mirror, and then it will turn and go in this direction. Now the original reflected ray is pointing to the left, but now the new reflected ray point this way. The question asks you to find this angle. Lastly, let me show you the solution of the homework.